What's the square root?
Something that can be multiplied by itself.
Exactly. Something that you multiply by itself 2 times. So I made a list on the back. You need to write these down so you can reference them because you'll really need them throughout everything we're doing today. All right, so it looks like this. That's what we call a radical, right? The number that we put in here, let's say 49, okay? We're asking ourselves what number times itself twice gives me 49. So this is 1, 2, 3, 4, 5, 6, and 7, so it would be 7, right? Now, if I throw this funny little sign in front, do you know what that means? Positive or negative. And if you think about it, the reason is, I told you it multiplies by itself twice, right? 7 times 7 is
49.
What is negative 7 times negative 7? 49. It can be positive or negative, okay? This little sign right here will kill you as you go through, and make sure you include that when you take a square root. All right, so that's kind of review. Kind of already assume that you know about radicals, right? What times itself twice gives you something. So what we're going to do today is we're going to talk about simplifying radicals. We're going to talk about simplifying radicals through multiplication and then through division. So first, let's talk about multiplication. Multiplication. So radicals have this neat little property, and this only works when you're multiplying. It doesn't work if you're adding or subtracting. In that if you're multiplying under a radical, you can split them up. So you can have the square root of A times the square root of B. And you can go forwards or backwards. If you start out like this, you can split them up this way. But if you start out with them already split up, you can put them together under the same radical. Okay? So this is convenient because what we'll have is let's say this radical here. Okay? And what you have to do to simplify, well, what you want to do is you want to find the biggest perfect square. And that's why you got this list behind me. The biggest perfect square to divide into it. Okay, divide perfectly, no remainder. I'll give you a second to copy that down. So looking at 32, if you look at this list behind me, I generally start pretty close to it. So can you divide 32 by 25 without a remainder? No. How about 16? Yes. 16 times what is 32? 2. So what I can do is I can say, well, this is the same thing as 16 times 2. Do you agree? Yes, no, maybe so? Okay. Y'all stay with me. And then I can split it up. And I can say, well, this is the same thing as the square root of 16 times the square root of 2. And the square root of 16 is what? 4. So this equals plus or minus. I got to do that plus or minus because I'm taking the square root. 4 times the square root of 2. So these are the same thing, but this one is simplified. Does that make sense? See if you can figure this one out on your own before I tell you. What did you get? What's the perfect square you found?
420.
Is it 16? I don't know. 16 and what? 5. 16 times 5 is 80. It's got one of the numbers has to be off this list.
I've got a copy of that list.
It could be a smaller one, but then you'd have to keep going and do it again and again and again. So you want to pick the biggest one. All right, so now I split it up, 16 and 5, and I'll show you. I'll do it where did you pick like 4?
Yeah.
Okay, I'm gonna show you if you didn't pick the biggest one, but you still picked one, I'll show you what happens. All right, so this is 4 square root of 5, and the plus or minus is my last step in the front. So Jordan asked a good question, and he said, what if you don't pick the greatest factor and you just pick a factor, but it's still from the list? So, for instance, if you had said 4 times 20 is 80, right? Anybody else pick 4? Maybe? A couple? Okay. You did?
No,
Oh, what? Okay.
So what about 5? 5 ain't coming out.
Only one of them has to come from this.
Alright.
Okay? All right. Square root of 4 times the square root of 20. The square root of 4 is 2. And I'm at this point. But I look at 20 and I go, wait. I can divide 20 by 4 again, right? 4 times what? 5. 4 times 5 is 20. So now I got 2 times the square root of 4 times the square root of 5. This is a multiply problem. So the square root of 4 is 2. And what's 2 times 2? 4. I end up with the same thing. It just takes me more steps. It's more work. So if you pick the biggest one to start with, you don't have to go through the extra steps. But if you don't, it's still not wrong, if that makes sense. What if I started out with 2 separate... What if I had 2 separate radicals, let's say 10 and 15? On their own, I can't divide them by anything. Do you see that? Do you agree with that? I would. I want to go ahead and put them together so that I can break them apart and simplify. So I could make this 150. And now I want to look at the 150 and I want to look at this list of numbers and say what's the biggest one on this list that I can divide 150 by. What is it? 25. 25 and what?
6.
Yes? Square root of 25 is? And then the square root of 6. By Taylor. Huh?
That's it, right? That's what we're doing.
We're going to divide 2. We're going to divide 2. Let's say, let me start it like this, division. So division has the same property that multiplication has in that I can split up. Okay, so if I have the square root of A over B, what happens is I can break that apart and say it's the same thing as the square root of A over the square root of B. Okay? Now, I can't have a radical in the denominator, so that's going to pose a problem for me for a lot of things in just a minute that I'm going to show you. But understand I can still break up either way. So the question is, what happens? Never leave radical in denominator. Look at a couple of examples. Let's say I had this and I was asked to simplify it. What do you do? Square root of 64 divided by the square root of 9. So now I need to look at simplifying each one of those. What's the square root of 64? 8. And the square root of 9 is, put the plus or minus and you don't have to go any further with that. It's done. Okay? Those were nice and easy because they were perfect squares. What if I end up with something like this? You need me to go back?
Yeah, go back.
Back to this one. What if I have the square root of 5 over 2 and I split that up? Is 5 a perfect square?
No.
How about 2?
Yes.
Perfect square?
No.
Not divisible by 2, not an even number, but perfect square. So my question to you is, can you split either one of them up? Can you divide them by a perfect square? No. So I've got to find some way to get that radical out of the bottom, because remember, we can't have a radical in the denominator. Does anybody know what you do?
Multiply by 2.
You're very, very close. Not by 2, but if I multiplied 2 times the square root of 2, I would just get 2 square root of 2. What could I multiply it by to get it to go? Square root of 2 times square root of 2. Because what happens is if I have square root of 2 times square root of 2, that gives me square root of 4, which then gives me 2. Okay, so that's a property you need to know. Any square root times itself, if I have the square root of 5 times the square root of 5, that gives me 5. Square root of 3 times the square root of 3 would give me 3. The square root of 7 times the square root, it doesn't matter what it is, if you're multiplying it together, that's what it gives you, right? Because I could combine them. It's that same multiplication property.
You could just, like if you're working through it, you could just take the sign off. Like if you just write out your word.
Well, but what you got to do, it's got to go because I'm multiplying by square root of 2, right?
Yeah.
Okay, but I can't do it to the bottom because then my fraction's not the same anymore. So what I do is I do it to the top and the bottom. Okay, so yes, you could just write 2 on the bottom, but you got to remember to take it to the top too. So when you have a radical in the bottom, we multiply the top and bottom by that radical. So that, yes, like you said, the bottom you could just write 2 because that's what's left. Up top, I would end up with the square root of 10. And then, of course, I would have to go back and look at my radical to see if I could simplify it any. Keep us occupied. Square root of 2 over 15. Split it up. Are either one of those perfect squares? No. So what I need to do, what do I need to multiply the top and the bottom by? Square root of 15, right? Up top I get square root of 30, and on the bottom, what's the property, Bryce? Look. What's the property? What's the square root of 15? Guys, y'all get together. Come on. Shh, 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 shh. Now I want to look and see, can the 30 be broke down? Can you divide 30 by any of these numbers?
Yes.
Which one? Yes, you cannot?
No, not.
No. No. Shh, 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 shh. Yes, no, maybe so? All right. Let me show you one like this because it comes up in your classwork. If you have something like this, okay, when I split that up, I get the square root of 5 over the square root of 12, right? So you can multiply the top and the bottom by square root of 12 as it sits right there. What I would probably do is I would look at this first and I would say, can you split that up?
Yes.
Yes, because the square root of 12 can be split up exactly, which is, yes? So what happens is, now I've got the square root of 5 over 2 times the square root of 3. So the problem is the square root of 3, right? So now you just, exactly, you just times it by square root of 3 top and bottom, which would give me square root of 15 over, don't forget that 2 in the front. What's the square root of 3 times square root of 3?
It's 3, which is 6.
Put the plus or minus in front. Yes? All right, get your